Hello, welcome to another discussion of Environmental Science 3. This is the curriculum of Sit and Use Construction Technology students. Today we are going to look at illumination. This is part 1 of illumination series that we are going to discuss as far as we are concerned. So at the end of this lesson, you are supposed to define the following terms: luminous intensity, luminous flux, illuminance, candela, lumen, lux, and you're also supposed to explain the laws of illumination and also calculate the levels of illumination of a surface due to a point source. So the laws are inverse square law and also the cosine square law. Measurement of light. Light is an electromagnetic radiation which can be detected by human sense of sight. The effect of light on human environment depends on the sensitivity of the eye. Solid angle. So whenever we are doing the measurement of light, we need to know something about the solid angle. Of course, the solid angle is it has the SI unit of steradian. So solid angle, if we look at the blue light, if we have this blue light, this is the source of light. Of course, we've cut the sphere into a half so that we can see the effect of light. So we have that which is beaming on the blue surface. So the blue surface is just a shadow of the light source from the center of the sphere. So assuming that we have the radius from the light to the surface, which is equivalent to the size of the square, that is equivalent to the size which are r and r. The square so formed, or the area so formed, the area of the blue part it will give us an angle which is equivalent to 1 steradian. In this case, we are trying to say that assuming that we have the distance from the light source to the corner of each sides of the surface, like as we can see on the diagram, that is if we have the distance, which is, for example, if the distance from the blue light to that corner is say maybe 10 millimeters, and also the distance from the corners of the shades from the light, like from here to that point, if it is also 10 millimeters, it therefore means that the area of this square illuminated by the blue light from this point is going to be 10 times 10. So 10 times 10 is equal to 100 square millimeters. So this area so formed, which has got its length equivalent to the radius from the bulb to that, it will give a solid angle which is 1 steradian. So that's what we call a steradian. A steradian is equivalent to the angle that is subtended, the angle that is subtended by the arc, which it has equivalent distance or the dimensions of the radius on the surface. So if we square, that is radius squared is equivalent to 1 steradian in that case. That is if we are to look at that. So maybe if we are to define that solid angle, so 1 steradian is the solid angle at the center of a sphere, which casts an area on the surface of a sphere equal to the size of its radius squared. So like what I was explaining, so you have this red part, which is the area formed by the shadows from that center part of the sphere. So we've just produced just a portion of a beam made by 1 steradian. So in this case, we are trying to say that the distance from that light source to the edges of that is equivalent to radius, and that is equivalent to radius. We have radius, and the distance of the dimensions of the shadow that is formed by the beam from the center is also equivalent to the radius. So in this case, if we are to find the area of this red part, is going to be r times r, so it's going to be r squared in this case. So that's 1 steradian in that case. That's if we are to look at the value of the solid angle. So if we want to determine the total solid angle around a point, that is around the sphere, we know that the total surface area of a sphere is equal to 4 pi r squared, and the area giving 1 steradian, as we have discussed, is r squared. So dividing r squared into 4 pi r squared is going to give us 4 pi. So that is 4 pi is the total, this 4 pi is the total angles, total solid angle around a point. So it means that a complete sphere in this case has got a total of 4 pi steradians. Another terminology that we need to know is the luminous intensity, and this luminous intensity is the power of light source or illuminated surface to emit light in a particular direction. So luminous intensity I is the power of light source of illuminated surface to emit light in a particular direction, and this luminous intensity is measured in candelas. Another terminology is the luminous flux. So this luminous flux is the rate or flow of light energy and measured in lumens. So the SI unit for luminous flux is the lumens. So 1 lumen is the luminous flux emitted within 1 steradian by a point source of 1 candelas. So if we look at this diagram, assuming the arrow, the cyan color or the sky blue color is the direction of the luminous. So if we have the light intensity of 1 candela, and then with 1 luminous intensity, then the flux of that particular lamp is going to be 1 lumen that will be illuminated in that direction. So that's what it means by that. And so we can come up with the general formula that relates the terminology that we have discussed. We have discussed the solid angle, we have discussed the luminous intensity, and we've also discussed the luminous flux. So this can be put into one general formula where we have I is equal to F over omega. So where I is the mean spherical intensity of the light source in candelas, and F is the luminous flux emitted by the light source, whereas the angle omega is the solid angle containing the flux and is in steradian. The another terminology that we need to know in as far as the lighting measurement is concerned is the illuminance. Illuminance is the density of luminous flux reaching a surface and is measured in lux or lumens per square meter. So the SI unit of illuminance is lux, or is the lumens per square meter. In fact, 1 lux is equal to 1 lumen per square meter. So if the light is that is supposed to be is, so there is supposed to be is. So if light is falling on a surface at right angles to the surface, then the luminance is given by the following formula, so which is E is equal to F over A, where E is the illuminance in lux, and F is the total flux reaching a surface in lumens, and A is the area of the surface in square meter. So the area of the surface is supposed to be in square meter. So for example, if we have this science laboratory bulb has a mean spherical intensity of 120 candelas, 1/10 of the total luminous flux emitted falls at right angles onto a surface measuring 2.5 meters by 4 meters. Calculate the total luminous flux emitted by the source, and also calculate the luminous produced on the surface. So we have been given that I is equal to 120, and also we've been given the solid angle because it's a spherical luminous. So in this case, it's supposed to be 4 pi, and the F is the one that we are supposed to calculate. So in that case, we have the formula, which is I is equal to F over omega, where I is the mean spherical intensity of the source in candelas, and F is the luminous emitted by the source in lumens, and also the solid angle in steradian. So if we want to make F the subject of the formula and substituting, we are going to have, of course, making this the subject of the formula, it means that F is going to be I times omega in this case. So substituting omega, that is 4 pi for omega, and also I 120 lumens, then we have this in the formula, that is 4 pi times 120 lumens. And the answer to that one is going to be 1507.96 lumens. That is the total flux that we are supposed to work out. And another question that we have been asked to work out is to work out the Illuminance. Of course, we have calculated, in this case we have calculated, we can calculate the area. Area is going to be 2.5 times 4, which is 10 square meters. And flux, we are saying 1/10 of the flux emitted falls at the surface, at right angle onto the surface. Then we need to find 1/10 of the total flux that is given out by the source. So in this case, you multiply 10 over 100 times 1 over 10 times 1507.96. In fact, 1 over 10 is equivalent to 0.1, so that's what we have. So if we multiply, then we are going to have 150.796 lumens. So using our formula, which is E is equal to F over A, where in this case E is equal to luminous, and F is the luminous flux emitted by the source, and A, the area, we have calculated the area, we have calculated the luminous that falls on to the surface, and then we need to substitute in the formula. Then we are going to have E is equal to 150.796 over 10, and dividing and correcting to 2 decimal places is going to give us this value, which is 15.08 lakhs. That's what we are asked to work out. And having calculated that, we know that we need to look at the behavior of the illumination as we move away from the source. So this could be the inverse square law. Of course, the inverse square law says that the luminous produced by a point source of light decreases in the inverse proportion to the square of the distance from the source. And this can be put into the formula where we have E is equal to I over D squared, where I is the intensity of a point source in candelas, and D is the distance between the source and the surface in meters, and E is the luminous on the surface in lakhs in that case. So if we are to put that into the diagram, then we have the light source, and then as you move away from the source, the area to be illuminated increases as the illumination reduces. So there we have D, and the distance is doubled, and the area will be 4A, and then we have that one. So that's the inverse square of illumination. So an example. So if we are to look at example 2, a torch has a luminous intensity of 1800 candelas and acts as a point source. Calculate the illuminance produced at the following positions. So for this, we are going to assume that we are going to assume that we have this as our light source that is working out. This is as our light source, and this is the distance from the light source. The first distance is 2 meters, and the next distance is 10 meters from the light source. Then we need to work out the luminous at 2 meters from the source, the luminous on the surface, and also luminous at 10 meters at the source. So working out, now we have in this case we've been given um, the luminous intensity, which is 1800 CD, and also we've been given the distance from the source. So given that is 1200 CD, I believe that is supposed to read 1800, so there is a mistake. It's 1800, so here is supposed to be 1800. It's supposed to be 1800. That is if we were to do the, yes, so that's 1800. Of course, if we were to go back to that one, so this is 1800. In fact, in the calculation we have we have that one, as we can see in the, so this is 1800 luminous intensity. So we use that 1800, and the first distance is 2 meters and the second distance is 10 meters. So using the inverse square formula and substituting, we have for a distance of 2 meters, it's going to be E is equal to I over D squared, which is I is 1800 and the distance 2 meters, so it's 2 square. So we have 1800 over 4, which gives us 450 lakhs. And for question B, that is at a distance of 10 meters from the source, so substituting into the formula, we have 1800 and also T squared is going to give us, that is D squared, which is 10 squared. 10 squared is 100. 100 into 1800, and it's going to give us 18 lakhs. So those are the answers that we are supposed to find from the question that we are given. So if we consider now looking at the cosine law of elimination, this is normally applied to where the light strikes surfaces at an inclined angle. So the law is also referred to as the Lambert cosine rule. So the cosine law of elimination can be expressed as E is equal to I over D squared cos theta. So that is if we are to have the diagram in this case, I is the intensity of the source and theta is the angle to the normal, and also the distance D from the source to that end, and that's the illuminance at this position. That's the one that we are working out. So in this, as we could see, we are saying that if we have that if we apply this diagram into our formula, so we are saying where in this we have I over D square, so where the I is equal to intensity of a point source and D is equal to the distance between the source and the surface, and E is the luminous at the surface. So illuminance at the surface, so we are looking at the illuminance at this surface, not directly above the the light source. Otherwise it would have been the inverse square law and not the cosine law of illumination. And the theta in this case, it is the angle, it is angle between the direction of the flux and the norm to the surface. So normal to the surface. So this line is normal to the surface, and that is an inclined angle. So the angle is the angle theta is the angle formed between this distance and also the normal to the surface. So that's the cosine law of elimination. And if we look at an example, let's say a street has a uniform intensity of 1600 candelas. It is positioned 7 meters above the center line of a 6 meter wide road. Calculate the luminance at the edge of the roadway. So in this case, we have this is the diagram. So working out, we can for you to work or maybe to let the examiners understand you properly, you need to you need to configure, or you need to put the equation into a diagram like the one that we have here. What I was saying, so you draw the lamp source. In this case we are drawing the lamp source anyway. If we had wanted, we would have drawn that diagram of a lamp that is showing a pole from under and then to the lamp, but in this case we just want the simplicity to show the source of the lamp, where the lamp is positioned, and also we have the distance, of course, the D, showing the distance from the lamp to the to the point. And so this distance from the road, from the center of the road to the ramp, is 7 meters, because the question says that it is positioned 7 meters above the center line of a 6 meter wide road. So the road is assuming this hatched rectangle is the road, and is 6 meters from edge to where the pole is positioned. And half of that is going to be 3 meters, because we need 3 meters to determine the value of D. That is, we are going to use the formula, which is E is equal to I over D squared cos theta. So we need to know the value of D by using the Pythagorean theorem. So in this case, we will use the Pythagorean theorem to determine D. As what we would have in the equation, we have 7 and also 3. So to determine D, this D squared is going to be 7 squared plus 3 squared. So that's what we have here. So 7 squared plus 3 squared is going to be 58. But then the value of D, then we have to find the square root of D, which is the square root of D squared. So it's going to be square root of 58, which is 7.6. So the value of D is 7.6. And also cos theta, we use the SOHCAHTOA, that is to say cosine is equal to adjacent over hypotenuse. So our adjacent side in this case is the 7 meters is adjacent to the angle, and the hypotenuse is D, which is 7.6. So we've calculated D to be 7.6, so we're going to say cos theta is equal to 7 over 7.6, which is equal to 0.9211. So there is no need of finding the inverse of this cos theta so that we can determine the angle, because we don't need the angle. What we need is the cos theta. So substituting into the formula whatever we have calculated, then we have E is equal to, that is the intensity, 1600, and over 58. 58 is the D squared. So value of D squared is 58. So you don't need to square 7.6, so that we already have 58, which is D squared. So you multiply this by cos theta, which we have calculated is 0.9211, which gives us 25.4 lakhs. That is the value we are supposed to work out. So now, after having discussed that, now it's time for you to work out these the following problems. The first problem is a classroom emits a total luminous flux of 1,500 lumens in all directions. Calculate the luminous intensity of the lamp. And the second question is a street lamp has a uniform intensity of 1,400 candelas. It is positioned 6.5 meters above the center line of the road, which is 8 meters wide. Calculate the luminous on the road surface directly below the lamp, and also calculate the luminous at the edge of the roadway. So those are the questions that here we had, and those are the ones that you're supposed to work out. Once again, thank you for your attention. Thank you.